what we're going to do in this video is graph some lines using the x and y intercepts of the line. So first of all, a line is defined by 2 points. So if you find 2 points, if you're able to plot 2 points on a line, then you can connect them and keep going in both directions, and you will have drawn the line. And what I'm going to do in this video, the 2 points I'm going to pick are the intercepts. The intercepts of the lines, and there's 2 of them. There's the x-intercept, and then there's the y-intercept. And these are the points where the lines intersect the x and y axes. And just to make it clear, this right here is the x-axis on my graph paper. That right there is my x-axis. It just keeps going. That's my x-axis. And then this right here in the middle going up and down is my y-axis. That right there is my y-axis. I don't think you can see what I just wrote. That is the y-axis right there. So let me show you what I mean by x and y intercepts. So let's do part A. So part A, I'll do it, let me do it in a different color, not the same color as my intercepts. Part A, we have the equation y is equal to 2x plus 3. So first of all, let's think about what happens when x is equal to 0. When x is equal to 0, what is y equal to? Y is going to be equal to 2 times 0 plus 3. Well, 2 times 0, that's just 0. So y is equal to 0 plus 3, or y is equal to 3. So the point x is equal to 0, y is equal to 3, that satisfies this equation, or it's on the line defined by this equation. So the point 0, 3. So let me plot that. The point 0, 3. Now notice, this point, this is when x is equal to 0. This sits on our y-axis. So we call this right here a y-intercept. It is when x is equal to 0. But it's called a y-intercept because it sits on the y-axis. This is where the line intercepts the y-axis. Now let's do the same for the x-axis. So let's set y equal to 0. So if y is equal to 0, we have 0 is equal to 2x plus 3. We could subtract 3 from both sides of that equation, and you get negative 3 is equal to 2x. We can divide both sides by 2, and you get negative 3 halves is equal to x. And negative 3 halves, that's the same thing as negative 1.5. So we know that the point negative 3 halves, comma 0, right? In the second scenario, y is equal to 0. We know that this set of values of x and y also satisfy this equation, or that this point also sits on the line. So negative 3 halves. So negative 3 halves, remember, that's the same thing as negative 1.5. That's right there. Y is 0. So that's that second point we just figured out. When y is 0, we're dealing with our x-intercept. We're intercepting the x-axis. That is the x-intercept right there. And then if I wanted to draw the line, it'll look like this. Very roughly, I'll connect those points and then just keep going. Keep going in both directions. Keep going in both directions forever. And then I will have drawn my line. I'll do one more of these. I don't want to make it too messy over here. Let me clear all this stuff out of the way. Let me clear this out of the way as well. You could always pause it if you want to gaze at it. Oh, I shouldn't have done that. I got rid of my, well, you can see still the axes. I'll redraw the axes. I'll redraw it right there. It's good enough. That's my x-axis, and that is my y-axis right over there. Let me do part B. B looks like an interesting one right there. So B has 6 times x minus 1 is equal to 2 times y plus 3. So let's look at the situation when x is equal to 0. When x is equal to 0, that equation up there becomes 6 times negative 1, right? Because this is 0. So 6 times negative 1 is negative 6 is equal to 2, let me distribute this, 2y plus 6. I multiplied 2 times the y and times the 3. And then we can subtract 6 from both sides so that you get negative 12. Negative 12. is equal to 2y. I subtracted 6 from both sides to essentially move this 6 onto the left-hand side. You subtract 6 here, this disappears. You subtract 6 from here, you get negative 12. Divide both sides by 2, you get negative 6 is equal to y. So our first point that we know is on the line is the point x is equal to 0, y is equal to negative 6. X is equal to 0, y is equal to negative 6. That is our y. That is our y-intercept. Now, let's see what happens when y is equal to 0. When y is equal to 0, go back to the original equation. We have, let me write that a little bit different. When y is equal to 0, we have 6 times x minus 1. Let me just distribute that. So 6x minus 6 is equal to 2 times y. Well, y is just going to be 0. So it's going to be 2 times 3. This whole thing is going to be 3. It's going to be equal to 6. So let's subtract 6 from both sides, or let's add 6 to both sides of this equation. I want to get rid of that right there. So I need to add 6 to make that 0. So we get 6x is equal to, you add 6 to the right-hand side, you get 12. And you get x, divide both sides by 6, you get x is equal to 2. So our other intercept is x is equal to 2, y is equal to 0. So we have x is equal to 2, y is equal to 0. Right there, that is our x-intercept. And then our actual line, we just connect the dots. Connect the dots. It will look something like that. Obviously, you have trouble drawing a straight line, but I think you got the idea. 2 points define a line. Let me do one more of these. I could probably do it up here, in this real estate up here. Let's do, I don't know, let me do part D. You can do part C if you want extra practice. So part D, we have x plus y is equal to 8. So this is actually very, very straightforward. When x is equal to 0, what is y equal to? If this is 0, all we have left is y is equal to 8. And then when y is 0, what is x? Well, you can just almost cover this up. Then you just get x plus 0 is equal to 8. X is equal to 8. So that was pretty straightforward right there. So we have 1 point, 0, 8. So 0, 8. That is the y-intercept. And then we have the point 8, 0. 8, 0. That is the x-intercept. And then we can connect the dots. It looks something like that. Now let's do this problem down here. At a local grocery store, strawberries cost $3 per pound and bananas cost $1 per pound. All right. If I have $10 to spend, between strawberries and bananas. Draw a graph to show the combination of each I can buy and spend exactly $10. All right. Well, let me draw my axes, make sure that these are nice and filled in. So that, remember, is my horizontal axis. That is my horizontal axis. But just for fun, instead of calling it the x-axis, I'm going to call it the strawberry axis. Strawberry. Actually, let me call it S, the s-axis, where S is for strawberries. So let S equal the number of strawberries. Strawberries, and I think you know where I'm going. B will be number of bananas. Bananas. And so let me do my b-axis. I'm going to plot the number of bananas on the vertical axis. So this right there, that is the b-axis. B for bananas. B for bananas. All right. So strawberries cost $3. So, okay, this isn't the number of strawberries. This is the number of pounds. So let me clear that up. This is pounds of strawberries. We're not going by the number of strawberries. We're going by pounds of strawberries. And this is pounds of bananas. All right. So strawberries cost $3 per pound. Bananas cost $1 per pound. So how much am I going to spend? I'm going to spend $3. I'm going to spend $3 times the number of strawberries, because they're $3, or I'm going to spend $3 times the number of pounds of strawberries, because it's $3 per pound, plus $1 times the number of pounds of bananas. And they say I have $10 to spend on both. So that's going to be equal to $10. So 3 times the pounds of strawberries plus the pounds of bananas are going to be equal to 10. 1b, that's the same thing as b. So I can rewrite this as 3s plus b is equal to 10. Now let's plot this. So let's look at the situation where I get no strawberries. So in the situation where I get no strawberries, so my pounds of strawberries are 0, what does this equation become? It becomes 3 times 0 plus b is equal to 10. That's just 0. So b will be equal to 10. So I would have to point 0 pounds of strawberries. I could get 10 pounds of bananas. So if I get 0 pounds of strawberries, I can get 10 pounds right there of bananas. Now, what about the other scenario? What about the scenario where I get no bananas? I get 0 pounds of bananas. Then let's substitute back here. We have 3 times my pounds of strawberries plus 0 pounds of bananas will equal 10. That's just a 0. Divide both sides by 3. If I get no bananas, I can get 10 over 3 pounds of strawberries. Or this is equal to 3 1/3. So we would have the point 3 1/3 pounds of strawberries, 0 pounds of bananas. So 3 1/3 pounds of strawberries, 0 pounds of bananas. And then we can connect the line. And this whole line I'm going to draw, I'm just going to draw it in the first quadrant, because I can't have negative bananas. I'm not going to sell pounds of bananas. And I can't have negative strawberries. We're not talking about selling strawberries. So I can only buy these things. So this is the amount that I'm buying. So let me connect the dots right there. And this is neat, because this line shows all of the possible combinations of pounds of strawberries and bananas. For example, this point right here. I don't know if I'm drawing it exactly. It looks like I have about 5. If I get about 5 pounds of bananas, I can get a little under 2 pounds of strawberries. That's what that tells me. If I get 3 pounds of strawberries, if I get exactly 3 pounds of strawberries, I can get 1 pound of bananas. Every point here represents a combination that I can get for $10.